Okay, today we are going to discuss about the main dimension problem. Based on the output equation, we need to find it out the main dimension of the machine, right? The main dimension in the sense diameter and length. It means you are going to design the machine to find the diameter and the length of the particular machine. They are given one problem. Yeah, 5 kilowatts, 4 pole DC shunt generator, square pole paste they are given. So the square pole paste in the sense, normally the pole it is like that. So the length of the pole and the pole arc, it should be the same. That is the B, it should be equal to L. So that problem itself they are given. Then the efficiency of the shunt generator they are given. That is the 0.87. It means the 87%, right? Then average magnetic flux density, then ampere conductor they are given. They are asking you to find the main dimension of the DC machine D and L. Then they are given the problem itself, square pole paste, the length of the pole core it should be equal to pole arc. Then so the pole arc to pole pitch ratio they are given in our problem, that is the 0.66. This is the given data. As per the given problem, we are written all the data from the problem, right? So in the particular problem, we are going to use the output equation. So output equation you all know. So that is the output coefficient, that is the C naught. Then they are given in the particular problem, it is the generator. So the PA, that is the developed power in the armature, or produced power in the armature, it should be equal to power rating by the efficiency. Then from the output equation we can find it out, D square and L, that is the PA divided by C naught N. Then similarly they are given B by tau, the value they are given, that we can consider as L by tau, because B it should be equal to L. Okay. So we are going to solve this particular problem to find the diameter and length, right? So the P it should be equal to 5 divided by 0.87. 5 is the power rating of the machine, that is they are given 5 kilowatts. So the 5 divided by 0.87 is the efficiency of the particular machine. So efficiency. So while we are dividing, we can obtain this value, that is the power developed, we can finally obtain 5.75 kilowatts. Then similarly we can find easily the output coefficient. So the output coefficient itself, that is the pi square BAV and AC. The BAV and AC value they are given directly in your problem. So you can substitute and you can find the output coefficient of the machine. That is the C naught, it should be equal 62.18, right? Then you can find the D square L. The D square L it should be equal PA divided by C naught by N, which is derived from the output equation. So D square L value you can obtain, the D square L value, that is the 3.7 into 10 power minus 3, that is the D square L. Then L it should be equal to, so we need to find it out, D and L value from the given problem. The L in terms of D we can find it out easily, because they are given one relationship, D by tau, it should be equal to L by tau. So the tau value we know, the tau is, we have one formula, that is the pi D by T. So we can substitute that value. So here this all constant, the pole they are given in the problem itself. So you can substitute this value, you can find L in terms of D, right? So L in terms of D once we are founded, again this L value you can substitute in the previous expression A. So you can find the easily D cube. So the D cube value we can obtain, that is the 7.1415 10 power minus 3. So while we are taking the cube root, from the D cube we can find it out D value. The D is the diameter of the machine, that we can find it out easily. Then after finding out D value, you can substitute this D value in the previous expression, L in terms of D. So this expression itself we can substitute in the D value here. So if you are substituted, you can find the L value also. Once you have founded the L value and D value, that is the main dimension of the machine. Okay. So then after finding out L and D, you can write the result, that is the diameter, then that is the length. So you can draw this diagram like that. The diameter of the machine, that is the D, the length of the machine, that is the L, that we are founded. That is the main dimension of the DC machine. So particularly the machine, if they are given in the problem itself, if they are given the efficiency, that we can consider as the generator. If they are not mentioned, you can consider as the generator, because we can know the formula, the PA it should be equal to P divided by efficiency. right? Similarly, the square pole pitch means that is the pole arc to pole pitch. That is the ratio of pole arc to pole pitch they are given. The pole arc it should be equal to the pole core length for the square pole pitch. Okay. If you know this assumptions is thoroughly, you can easily solve and find the main dimension of the machine diameter and length. Okay.